Another very important theorem for vectors is the cross-product angle formula, which says that if theta is the angle between the vector A and B, then the length of the cross product, A cross B or B cross A, doesn't matter, is equal to the length of A times the length of B times sine theta. So just like dot product, the cross product also captures the angle, although in a different way. Well, we will not prove the cross product angle formula. Instead, we are going to make use of it to study two problems in space. The first one is to find the area of a parallelogram, and the second one is to find the distance from a point to a line in space. So now let's consider a parallelogram spanned by two vectors A and B. By this we mean the parallelogram whose adjacent sides are the vectors A and B. So here we have the vector A at the bottom, which is adjacent to vector B on the left hand side and also on the right hand side. Now at the top we also have the vector A. So this is what we mean by the parallelogram spanned by the vectors A and B. Now the problem is to find the area of this parallelogram, and from elementary mathematics we know that the area is actually equal to the length of the base times the height of this parallelogram. Here I'm going to take the vector A to be the base, so the length of the base is just the length of the vector A, and the height can be determined by using the triangle formed by PQR, let's say, and we can see that using the angle theta, the height is just the length of PR times sine theta, which is length of B times sine theta. Now by the cross product angle formula we know that this is just the length of the vector A cross B. Hence we have shown that the length of the cross product of A and B is actually the area of the parallelogram spanned by the vector A and B. We now turn to the question of finding the distance from a point to a line. By distance, we always mean the shortest distance. As you can see in the picture, the distance from the point Q to the given line is always the length of the line segment which is perpendicular to the given line starting from Q and ending at the intersection point down here. To find this distance, we first pick any 2 points, let's say the point P and R on the given line, and form the following two vectors, one directed from P to Q and the other one from P to R. It now follows from the right angle triangle containing the point P and Q that the distance is equal to the height of this right angle triangle, which can be computed as the length of the vector PQ, which is the length of line segment from P to Q, times sine theta, where theta is the angle between the vectors PR and PQ. If we like, we can rewrite this expression using the cross product angle formula, giving us the length of the vector PQ cross PR, the vector PR divided by the length of the vector PR. So we have arrived here at the formula for the distance from the point Q to the line passing through PR. Now looking back to our argument, there is no reason why the point P that we pick is always on the left hand side of Q, whereas R is on the right hand side. For example, let's say both of the points P and R are on the right hand side of the point Q, And let's say theta is the angle between the vector PR and PQ as before. Then it follows from the right angle triangle that the distance that we want to compute is given by the length of the side PQ, or the length of the vector PQ, times sine pi minus theta. So here we use this angle right here, which is equal to pi minus theta instead of using the angle theta. So this is equal to the length of PQ times sine theta, because theta is in the second quadrant, therefore sine pi minus theta is the same as sine theta. So as before, this is equal to the length of the cross product PQ cross PR divided by the length of the vector PR by using the cross product angle formula. Now indeed we have the same formula in all cases, so it doesn't really matter if we have started with PR on different sides of Q or on the same side of Q.